Welcome to this video. I want to talk a little bit about serverless platforms on top of Kubernetes. And this is a presentation that I will be doing at DevBCN and KCD Spain this week. So let's get started. My name is Mauricio Salatino. I work for a company that is called Diagrid. We are building a bunch of stuff on top of the Dapper project. I'm a software engineer, but I'm also a CNCF ambassador. I wrote this book and published this book for Manning titled Platform Engineering on Kubernetes. And today I'm specifically focusing on serverless platforms. And I'm a project maintainer working on the Dapper project, the KCD project, and also the Captain project. You can check out my blog, salavoy.com, or find me on Twitter at salavoy2. Feel free to reach out, feel free to check out the book. I wanted to start this presentation talking about serverless, and the idea of serverless, if you're not aware of, is very usually associated with the idea of running functions like lambdas in AWS, where you just run a piece of code that will execute something and then it will be downscaled if it's not being used. The same idea applied into Kubernetes gets a little bit more tricky because by default Kubernetes doesn't have that functionality. When I talk about serverless, I'm not only talking about functions, I'm talking about any kind of application that can be upscale and downscale. But the downscale and upscale side of things is just kind of like the beginning. When you start looking into platforms, you will start talking about abstractions, and having the right abstractions and having the right tools behind those abstractions is extremely important. So let's start by checking a project that I don't know how many of you know about, that it's titled Open Function. Right? Open Function is a CNCF project. It's there on the incubating stage. The website is openfunction.dev. And basically this project provides a function as a service platform for you to run your functions on top. I think that the name doesn't make justice for all the functionality that this project provides. If you look into their documentation, what you will see is this architectural diagram, which shows all the different aspects that this platform is going to take care about our functions, right? It will start by building our function into containers, and for that you can use different projects that you can see here, like Buildpacks, BuildKit, or Canico. All of these projects are different ways to actually create containers from source code, right? Imagine that you are a developer, you are creating your functions, and you want to run them on Kubernetes, so then you basically need to create containers. And these utilities will make your life easier when building these containers instead of just defining Docker files. So you can see the next step is, basically making sure that you can take that container and put it in a cluster. And when you put it in a cluster, then the next thing that you want to do is you want to basically access to that function. That's the serving part. It will involve different components, as you can see, different projects to do different things. You're writing functions, you want to access to them. In order to run them, you need containers. And then when you put them in a cluster, you need to have a URL so you can call these functions. For all of that, you will see we will be talking about these projects like Dapper, Keda, Knative. We will not be talking about Wasm, but Wasm is another kind of way of running your functions too. If you take a look at open functions, I wanted to quickly show you an example. I have an example here in my GitHub repository that it's titled KCD Spain 2024. If you want to go and access and check the source code, this is a very, very basic function that basically doesn't do much, but it just we will be running this in our cluster. It's just a hello world function. So if you check this source code, let's do functions go. This is a Go function. It can be a function in any other language, right? Like the idea here is that you can just create in any language you want, because at the end of the day, it will be a container that will run on a cluster. If I cut this file, of course, we have YAML files because we are working with Kubernetes. This definition, it's a little bit longer, but actually it's a new type defined by the Open Function project. And this new type is function. So as you can see here, there is our first very, very high level abstraction. We want to define what the function is. And for that, we need to basically define all these things that we have here. There are a couple of things that will immediately caught your attention, which is build. So how are we going to build our functions? And in this case, we will start from the source that it's located in this repository inside this directory, functions go, right? Again, this functionality provided by Open Function will just take any source code in any language from any repository, and it will pick it up, and then it will build it with the builder that you define. In this case, we are going to use this builder here, that I think that out of the box is using Buildpacks. We will need to configure this with a bunch of parameters. As you can see here, like if you're running in China, you might need to have some proxy here just to access your Go modules. The next thing that we're going to see here is that the serving side of things. So we need to build it, and once it's built, we are going to have this running inside of our cluster. And for that, we're going to be using a project that's called Knative that will take our container and it will provide you with an URL. Right. So in this case, we're just not configuring much, but if you need to configure, for example, environment variables and stuff like that, you will put it here. For me, as a developer, but also like as a platform engineer, I just need to click in here, like the implementation details of which projects I'm using in the back to build, this function. And if you take a look into the documentation, you can see that you can go and fine-tune exactly which builder do you want to use and some parameters that for a developer might be way too much. Let's just apply this, right? Let's function. First of all, let me do get pods. I have no pods running in here, and I have open function installed, which basically installed a bunch of things, right? Like I have open function, shipwright, I have Tecton, I have Knative serving, Keda, and Dapper here installed, and everything is running on my GKE in a GKE cluster in Google Cloud, right? So let's do apply -f function.yaml. Even if I don't have the source code locally, it will pick it up from GitHub, clone it, build it in the cluster, and then at the end of the day, I should be able to call the function, right? So if I do get functions, because this is a CRD, this is a Kubernetes resource, I should be able to query it here. Let me make it a little bit smaller so it can fit the screen. Here, I just wanted to show you in a single line. You can see here that I built the function before, so the build is like I didn't change the code, so it succeeded, it's running, and I can have here, a URL. Kind of interesting, the URL doesn't provide you like the public address, right? Like because this is like an in-cluster function name, this is called function sample. So I will need to do a bunch of different things when it becomes a little bit tricky, right? So if I know I'm using Knative serving, I can just run this command, which basically will give me all the Knative service resources. And this is going to give me the external URL for the function. So you can see here, I'm translating from this URL to this one, which is the actual URL that I can use from outside the cluster to call the function. From inside the cluster, I can use this one. If another function wants to call this function from inside the cluster, that's fine. But if I want to call it from outside, I need to know some implementation details in order to get this URL. As you can see, this URL doesn't have a one-to-one mapping, like it doesn't even have the function name, which is a little bit strange. So there is a couple of things there that the open function project is not giving you out of the box. Let's call this function. Let's see if we can call this function HTTP, the URL of the function, and we can say KCD Spain, right? Let's see, you can see like the function is being called, but because it's not upscaled, it's going to start now, probably. And in a few seconds, we can get the hello world. It took some time because now if I do get pods here, we will have a function that is running in our cluster. And after 90 seconds or so, if I do not keep calling the function, it will just be the downscale automatically. And that's the beauty of functions, right? But again, I showed a couple of things, right? Like the builder tool that we're using to create a container, plus, need to know like some underlying details of networking in this case and the projects that I'm using in order to access the function URL. You install it in your cluster, you get the function abstraction, and you can create a function and you will get something up and running there. The question that you will need to ask yourself about open function and projects like open function in the future, if you're evaluating them, is that if they work for you, right? Do they have the right abstraction? Do you want to use that function abstraction? Is it the right interface for your teams to use? Sometimes these interfaces are too complex or they are trying to cover way too much ground, so you need to be careful with that. Then the tools that are being used by open function are the right tools for you to use. I would say that for most cases, I've seen people combining these tools together, but creating their own interface. Or is it like, are they exposed in a way that you are removing some of the complexity of these tools from your users? And then the question is like, are these abstractions the right ones, or they are pushing you to learn about all the tools that are being used in the back to implement these functionalities? Because if you start pushing your developers or your teams to learn about all these tools, they will spend a lot of time. And I think that it's important to mention at this point that projects like these will save you a lot of time just to create examples, but the more complex the projects are, the more complicated the use cases, and sometimes, again, this abstraction do not cover those use cases. So you need to think about it. And then if you have questions with this, who are you going to ask? Are you going to the open function community or to the individual communities behind these, right? So all these questions are things that you need to keep in mind when you're building these kind of abstractions. What I wanted to do next is I wanted to show you an application that we have built using some of the projects that Open Function is using. We're not using Open Function, but you're using some of these projects, and then talk a little bit about why these projects are important in the context of serverless platforms. So let's do that. Okay, so let's talk about the example application that we have that we will be interacting with. The application has 3 different user interfaces, and it's based on a famous Docker example that you can find online. I will share the link of the fork that we created just to extend the application. The application has a bunch of services and a bunch of infrastructure on the background, and it's now running on Google Cloud on top of a Kubernetes cluster. The main idea here is that you can vote between cats and dogs. And I will, like you can see, we have a lot of votes for dogs now, so I will just vote for a cat. It's picking the results up. Now there is like some events happening here whenever somebody votes, right? So we vote for dogs, we got for cats, we got some cat emojis. And there's some other functionality here that we will talk later on the presentation. But the application, it's pretty simple. It works like that. You can cast votes, you see the results, and at the same time you see dynamically in real time when votes are being casted. Imagine a bunch of people voting here. Just need to make sure that this application can scale, and because it's running in a Kubernetes cluster, you also want to make sure that you can access to this application. To get this working, we have the application and we have the application services. The application architecture is pretty simple. We have the vote user interface and the vote service that is running on the cluster, that it's connecting to Redis, and it's also connecting to RabbitMQ to emit messages. There is the worker application here that it's connecting to Redis and to PostgreSQL to basically create a view of the data for the result service to pick up. The worker doesn't have any user interface, it's just picking up data from Redis, translating that data into a new structure, putting it in Postgres. The result service can query the PostgreSQL and show the results every 2 seconds. We are sending asynchronous messages to the cats and dogs dashboard that is basically showing every time that somebody casts a vote in real time. We have different things like a worker. This needs to be triggering things every 2 seconds. That doesn't match the concept of a function. And then we have some UIs that again doesn't match one-to-one the concept of a function. So using the function abstraction might not be the best idea. But the first thing that I wanted to talk to you is Project Knative Serving, that basically will allow you to deploy these applications into your cluster and then just have an URL so you can access to it. This is very important when you have like things that you want to access from within the cluster and from outside the cluster. How do you define how these services are deployed? Right? Like you don't want to be defining 4 or 5 different YAML resources. You just want to create something very, very simple using the concept of from container to URL, right? And that's exactly what Knative Serving is doing here. So let me show you that. I connected to a new cluster now. The cluster that I'm connected with is running these services that we saw in the application. And Knative Serving has this new type called Knative Service. This is a new CRD in Kubernetes that basically you can query. It's the same thing that I did before in Open Function because I knew Open Function was using this. I can see here that I have 3 services with all public URLs. In this case, I have the right URL just to access this. That's the URL that we're accessing actually to cast votes and to see the results and to see also the dashboard. So I can describe the Knative service, in this case the vote service, just to see how it looks like, right? And I have a bunch of environment variables. This is because I'm using other projects too. But in general, the only thing that you need to specify here is the image name, the environment variables that you want to set up to that container, and Knative will take it from there, right? It will create a deployment, it will do a bunch of other things for you automatically out of the box. Because this is a UI, I didn't want to wait for the application to start, so you can actually set how many replicas do you want to have as minimum, right? Remember that Knative will do the auto-scaling up and down. So if we have a lot of people voting at the same time, we can actually push this UI to basically upscale for more replicas. And everything should work, right? Again, we want to make sure that we build this resilient, platform that people can use, and it will be automatically using more resources if there is a lot of demand for it. In general, again, in Knative, you just define the image that you want to deploy, in this case, this image, and the environment variables on how do you configure that application. But if you don't need to configure anything, you can just remove all that stuff. And Knative will provide you this at the end of the day, right? So it will provide you a pod that it's running here with the proxy that will deal with the scaling. So it has a small proxy to check, how many requests is it getting. And this is not being downscaled. Sorry, it's this one. This is not being downscaled because it has one minimum replica defined there in the descriptor as an annotation. Knative can be installed in the cluster. It's a Kubernetes extension that you can install, and it will install a bunch of things like a networking layer to be able to deal with all this, auto-scaling and all that stuff. It will do a bunch of other very useful things for you. For example, automatically provide like HTTPS for your connections. I didn't configure that because I'm just lazy, but it's just a flag. You just turn it on, and using Cert Manager, it will provide you a certificate for having HTTPS traffic there. It can also do traffic splitting and a bunch of other things that if you're considering building a platform, Knative is usually one of the things that people use. You will find it in OpenShift. If you're using OpenShift, this is a Kubernetes distribution by Red Hat, and you will find it there. If you take a look at Tanzu from VMware, also it has it there too, because it makes a lot of sense for teams to have this kind of functionalities. So check it out. Okay, so we just quickly recapped kind of like what we saw with Knative. With Knative, we got this idea to go from container to URL. We provide the container image, we will get the URL when it's running inside the cluster. It provides that simplified interface provided by this new resource called Knative Service. That's the one that I was querying using kubectl. It provides that idea of auto-scaling simplified, right? How to automatically scale up when we're getting a lot of demand. I also mentioned that we have traffic splitting capabilities because Knative installed a networking layer that can be provided by different tools like Istio or Courier or Contour. The addition of the networking stack will allow us to implement different release strategies, for example. But what about asynchronous autoscaling? Knative works by looking into HTTP request and figuring out if you need to scale up or scale down. For asynchronous autoscaling, you will see KEDA being mentioned quite a lot. When you have a message broker in a message queue and you want to make sure that you scale up your workloads based on the amount of messages inside the queue, that's what basically KEDA does for us. What about like application concerns such as observability, resiliency, and access to infrastructure? That's kind of like what we're going to take a look at next. And for that, we're going to go back to our open function website that basically shows a bunch of projects here. So we saw Knative already. I mentioned quickly KEDA. KEDA can also be used for autoscaling HTTP traffic. But in general, in the open function documentation, you will see that it's been mentioned a lot when you want to scale up based on Kafka messages or RabbitMQ messages. And then you will see Dapper. This is the project that I've been working on for the last year and a half or so. And in the open function documentation, you will find it here in this section that it's called BAS. And this basically backend as a service idea that they described here in the documentation. The idea here is to provide an abstraction layer for doing messaging like PubSub between services, service-to-service invocation, and implementing access to different infrastructure like key value stores or message brokers or secrets. In the open function documentation, they spend a lot of time trying to figure out how to provide the function experience not only as a container, but also as a programming model. And for that, they use Dapper for interacting with infrastructure. And for our application, this basically means interacting with Redis, interacting with PostgreSQL, or interacting with RabbitMQ. Instead of going straight like the function going directly to call these components from the infrastructure, it will use Dapper, which is basically an SDK that will connect to a sidecar that is going to be injected by very close to your application, providing access to all this infrastructure via APIs. So the application itself doesn't need to know how to connect to a database or to Redis or to RabbitMQ. It only needs to understand how to use a set of APIs that will make these connections for them, right? And Dapper will be sitting right there, basically exposing APIs and connecting to the infrastructure. If I show you in the cluster here, I'm using something that it's called Dapper Shared, mostly because when you run Dapper by default, it will run as a sidecar. That basically means that it will be attached to your application lifecycle. If you have functions, and you will see here in the open function documentation, is that they actually discover that when you have functions that are going to be downscaled, something that for some use cases, you don't want to do is downscale the Dapper APIs too, because maybe you want to be listening for a message to trigger a function. You downscale your function, but then you need to have something waiting for the function to wake up when a message arrives. And for that, I'm using something that is called Dapper Shared here, and I can show you here that I'm running, for example, for each service, I'm running something that is called Dapper Shared besides it, right? In this case, it's a separate deployment. So you can see here I have my Knative service for voting and a Dapper Shared connection to it. I have different implementations. I'm using now the Java implementation, which uses Spring Boot, but I also have a Go implementation of this service that basically uses Go to access these APIs. The application will know where this service is. Basically, there's a service there exposing APIs. So from a development point of view, you need to know is how to interact with those APIs. I have a Go example here for the vote service, and you will see here in the main Go function is that I'm using something that's called the Dapper SDKs. If I want to save a vote, I do save state. I'm just using the Dapper APIs to save state. I don't have any configuration to connect to the Redis instance that it's being used to store the votes. My application will not connect. We will delegate that responsibility to Dapper. This allows us to create applications that use these APIs as part of the programming model. So developers doesn't actually need to learn about how Redis works or how to use the Redis APIs. Or if we want to publish a message into a message broker, we don't actually need to learn about Kafka or RabbitMQ. That's quite a good advantage if you have large teams and you need to train like an entire company to learn about Kafka. The Spring Boot integration things looks a little bit different. Again, because it's Java, but also because they have some other interfaces that we can leverage. I'm leveraging these two interfaces, the Dapper key value template and the messaging template for Dapper. Instead of using the Dapper APIs directly, I can use the Spring Boot idioms. If I want to submit a message, I will just do messaging template send, and I will send my vote into a topic that I define here. Again, I'm not defining here if I'm using Kafka or RabbitMQ. I'm using Dapper to interact with RabbitMQ in this case that is running on the cluster, but I do not have any RabbitMQ dependencies in my application. I did save state, and I can do the same with the Dapper Java SDK, or I can use the Spring Boot integration that will allow me to use the key value template interfaces that are provided by Spring Data, for example, just to update the vote. And in this case, it's completely transparent. It's part of the Spring Boot, programming model. We presented this at Spring I/O a couple of weeks ago, so check it out if you're interested. The application code now is interacting with the infrastructure without adding the dependency of this infrastructure. Your applications are much more decoupled from infrastructure. And as I mentioned before, Dapper works by configuring some of these details on the cluster itself and configuring Dapper instead of our applications. And you can find these specific results for Dappers by listing components here. So these are Dapper components, and you can see here that I have the infrastructure required by my application configured in this way. So if I describe one of these components, what you will see is the configuration details to connect to Redis in this case. I have a Redis instance running here in my cluster, and this is a Dapper component, and basically its type, the type is state Redis. So this component is implementing the state store APIs, in this case implemented to connect to Redis. Redis is located in this service name in my cluster with no password in this case. And then I have a bunch of things on how to index data and stuff that is specific in this case for these kind of things. And then for sending messages, as I mentioned before, I have RabbitMQ. You can see that I have a RabbitMQ server running in there, and there's a service also, but I also have a component called PubSub that basically will connect to RabbitMQ in this case. So if I describe component PubSub, you will see here that basically it's doing the same where RabbitMQ is, like that's the name of the hosted service, then the username and the password that it's being consumed by a secret, right? The beauty about these things, about this component, is that I can change the type. So I can change the type of this to call it, for example, Google Cloud PubSub. And I don't need to change anything in my code for my applications to start using Google PubSub as a message broker. The same with Redis. I can change it for like, any Amazon provided key value store, and then my application will keep using the same APIs. No code changes are needed. The only thing that we are doing is we are configuring different infrastructure. So hopefully that makes sense. Also, for me, as a validation that if you're gluing things like Knative, Keda, Dapper becomes the next step of bringing kind of like developer concerns into the platform architecture. So if you are into that of creating kind of like a development experience with your platform with different services, please check it out. Let's quickly take a look at how Dapper works. By the way, Dapper stands for Distributed Application Runtime, and it's something that you install on your Kubernetes clusters. And we have been using kind of like this boat example application, right? How it works, when you install it in your cluster and you have applications that wants to interact with the infrastructure, in this case RabbitMQ and Redis, like the bot service, we will deploy the application. We will annotate it with Dapper annotation, and by default, the Kubernetes cluster and the Dapper control plane will automatically inject a sidecar into this application pod. A sidecar, if it's not something that you're aware of, it's basically two containers running in the same pod. So they will be sharing the same networking namespaces. So when they want to interact between each other, they will be using localhost to connect. And the Dapper sidecar will expose a bunch of HTTP and gRPC APIs. That's what we refer to as Dapper APIs in general. And that's why I was showing kind of like, the Dapper SDKs talking to these APIs. This Dapper sidecar will read a bunch of configurations in the environment. For example, the components that I showed you before. And these configurations are going to be used for the sidecar to connect to the infrastructure, right? So it will connect and listen to this infrastructure. It will create a bidirectional connection there. And at the same time, exposing all the functionality that this infrastructure is providing up to developers via the APIs. We have stable APIs. That basically means that we can just swap the implementation just to interact with Google Cloud or to interact with AWS services. Now our application is independent from whatever it's sitting behind these APIs that the Dapper sidecar is providing. And that will save you quite a lot of time if you're deploying the same application in different environments, if you want to deploy it in different cloud providers, but even for development purposes, right? Like sometimes you just want to run the application locally, you want to connect to an AWS service, you can start the container to, bootstrap Postgres. As we are doing this sidecar approach, then we can enable other things too, like service-to-service invocation in a resilient way, right? Like we can implement retries, circuit breakers, and do service discovery, because now when application both wants to talk to a different service, it can go through the Dapper sidecar to do this connection and basically implement best practices at that level too, without pushing the application to add, for example, a retry mechanism in code. We can handle this at the infrastructure level now. We can also get a lot of things for free, like MTLS. Now we can configure encryption between the sidecars, and also we can capture logs, metrics, and traces at that level without touching anything from our application. We can implement all these things to talk to external services too, right? Like we will have retries, circuit breakers, and everything with external services that we want to connect to. Maybe located in a different cluster, maybe it's a third-party API or whatever. We will just get the same benefits, and we will get all the resiliency built into this model. Dapper provide all these application concerns best practices via APIs for developers to use. As I showed you, we can use the Spring Boot integration, we can use the Go SDKs, you can use it in .NET, in Rust, and in a bunch of different languages. The main idea here is that we are separating infrastructure from application code and supporting different providers. That will make your application way much more portable across different environments, as we have a unified API that will work no matter what's configured behind those components. Before we finish, we need to talk a little bit about the infrastructure, and for that, I will be quickly and briefly talking about crossplane. Managing these kind of applications and these kind of environments, it's complicated. And you not only need to manage your workloads and your applications, you also need to manage the infrastructure that is being used by these applications. And I strongly believe that crossplane provides a very good alternative for managing these kind of things using common things that we use in the cloud native space, like GitOps, for example. What you can do with crossplane, configure declaratively provision cloud resources. The phrasing is changing a little bit about the control plane framework for cloud native delivery. You can extend Kubernetes to provision cloud resources no matter where those cloud resources are. I'm running on GCP now on Google Cloud Platform, and as you will see here, you will have different quick starts for different cloud providers. But also you can do things on premises. If you're not running on a cloud provider, you can also use Crossplane to provision stuff locally. How does it work? You install it on a Kubernetes cluster. This might be called like a management cluster. It's not the cluster where your applications are running. What you do is you install like the main control plane, which is the Crossplane project. You install it using Helm. Maybe we can try this here. So we can install Crossplane in our cluster. Well, that's going to be installed only just the main component, the main set of components, right? Then what you do is you need to choose a provider, depending on what kind of cloud provider you have. And for that, I have GCP, so I'm here in the GCP provider. And you install it like by creating a new resource and installing some specific packages that will give you access to the GCP, like the GCP APIs to provision resources in that way. You create a bunch of secrets and service accounts so Crossplane can go and create resources on your behalf. Once you have all these credentials and everything in place, you can start creating resources by sending some Kubernetes resources to your Kubernetes cluster. So if you want to create a database, then basically you will create a YAML file that describes the GCP database that you want to create, and then you will send it to your cluster that has Crossplane installed. In this case, it's a GCP bucket, right? So it's a bucket resource, and it has a bunch of different things, like for example, where it's located, in this case in the US, and then all the other things are provided by default. You have a bunch of defaults per kind of resource, so you will get the default bucket that you can go and create from the GCP interface, but create it declaratively. You may be wondering, why do I want to do that? Like all these things that I have installed here, like RabbitMQ and PostgreSQL. So you will see here that I have a PostgreSQL instance, I have a RabbitMQ instance, and I have a Redis instance. This is not usually the way that you will run your applications, like managing your own infrastructure. You probably want to use a cloud provider infrastructure, right? So these three components are perfect candidates for creating these kind of resources. So a Redis instance, a PostgreSQL instance, and probably Google PubSub for the message broker, right? So we'll have three different resources, all stored in a Git repository, and then use tools like, for example, Argo CD for syncing resources declaratively against my Kubernetes cluster. But the main idea here is that you will be combining these things to provide that kind of platform experience for your serverless workloads. The idea of showing you open function is for you to have a reference of something that you can do. But as you can see here, maybe in your company, you don't want to build containers in this way because you already are using GitHub Actions. Maybe you don't want to deploy these things using the function interface because you're already using Argo CD to create your environments where your applications will run. That basically means that probably you're using GitOps to change Git repository content to be able to sync which functions are running. So in this case, we are showing kind of like these tools. Unfortunately, as a platform team, you will need to learn about these tools and how to combine them together for your teams, and then try to create these abstractions that will allow you to be a little bit more flexible and simplify the experience for users that don't understand all these tools being used together. And I think that that's the closing thing that I want to mention here, is that if you start looking deep into Crossplane, one of the main things that they provide is the concept of compositions, right? And this is where it becomes really powerful, because now you're not only creating, cloud resources like databases or networks or buckets, right? Like you are composing a bunch of resources. Let's say my three infrastructure components, PostgreSQL, Redis, and I am just composing the configuration of all these three things, plus my applications configurations. And I'm saying, every time that I want to deploy something, I will just have a single resource without creating any Kubernetes extension. I will create a Crossplane composition that will allow me, by deploying a single resource, get all these things configured in GCP or in AWS or in Azure with a very simplified interface. You will notice here that they have something now called composition functions to enable some more dynamic scenarios. And I strongly recommend you to check this out, because again, this is where things becomes much more simple. And this is where you can start exposing your own interfaces without going and creating your own controllers or going through the process of understanding how Kubernetes works and how do you extend it. There are projects already doing this for you. So as a platform team, you should try to use as many tools that already exist as possible. That's kind of like what I tried to explain during my presentation at KCD Spain. It was a pleasure to be there. And hopefully you enjoy this recording, even if it's a little bit messy. I wanted to just give you all the context and all the pointers for the entire presentation. So thank you very much for watching. And if you have any questions, please feel free to reach out in Twitter or just drop me a message in my